Okay, so this video is going to give you some more information about vector addition. On the notes, we're going to graph them and do them algebraically because I want you to sort of see the connection. But on the worksheet, you will not have to graph them, okay? But I want you to be able to see this. All right, so again, I'm just following the directions here. So it says to draw vector A, which goes to the right 3. Again, you can start anywhere. So I'm going to go to the right 1, 2, 3, and down 6. Oh, well, I guess I can't start anywhere. Let me start a little bit higher. Let's go like this. 1, 2, 3, 1, 2, 3, 4, 5, 6. So here is vector A. All right, and then vector B says to go left 4 and up 1. 1, 2, 3, 4, and up 1. So here's vector B. Okay, so now that I have A and B, down below it says find the sum. Okay, so that means adding them. Now, you remember from previous lessons, that means I need to go head to tail. So let's see, I need to go, let me draw A again. 1, 2, 3, 1, 2, 3, 4, 5, 6. So here's A. And then I'm going to draw B, connecting the head to the tail. So up 1 and over 1, 2, 3, 4. So here's B, which means that my result goes from the original tail to the new head. So that right there in blue is the result. Now, algebraically, I just have to add these up. 3i minus 6j plus negative 4i plus j. Again, combining like terms, here I get negative I. Here I get negative 5. And then let's just double check. Is this what this picture actually looks like? Does it look like left 1 and down 5? Left 1, 1, 2, 3, 4, 5? Absolutely. All right, so you can kind of see the connection between the graph and the algebra. Okay, so let's try another one. So this one's saying let's subtract. Okay, so let me draw A. What color have I been doing A in? Oh, well, that's not good. Give me a sec. All right, I've been doing A in purple. Okay, so A in purple. All right, so let's start, I don't know, here. I'm trying to figure out where is a good spot to start so I can fit everything. Let's start here. All right, so A is right 1, 2, 3, and down 1, 2, 3, 4, 5, 6. There's A. Okay, now since I'm subtracting B, that's the same as adding the opposite of B. So I'm going to go right 4 and down 1. 1, 2, 3, 4, and down 1, right? The opposite of what I was doing before, which means that my result is from the original tail to the new head. So this should be A minus B. Now let's actually do it algebraically and see if that's what we get. 3i minus 6j, and this time I'm subtracting the negative 4i plus j. Distributing and combining like terms, we should get 7i minus 7j. Is that what this blue one looks like? You can count it yourself, but it absolutely does. Okay, scooting this thing up a bit. Okay, I'm doing A in purple. Now this one's saying 2 A's, all right, which means I need to double it. So I'm going to start way, way, way up at the top, all right, because again, A is 3 to the right and 6 down. So 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so this purple is 2 A's. Okay, now I need to do minus 3 B's. Okay, so usually for B, you go left 4 and up 1. So I'm going to be going right 4 and down 1, but 3 times. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Okay, so here in pink, this is my 3 B's. So then in blue, again, from the original tail to the new head, and I apologize if this doesn't come out very straight. I'm doing the best I can. Yeah, that's horrible. Sorry about that, but you guys get the idea. Okay, but let's do this thing algebraically. Okay, so I'm going to have 2 A's minus 3 B's. All right, distributing 6i minus 12j plus 12 2i minus 3j. And combining like terms, we get 18i minus 15j. All right, and again, you can count that out up here. I mean, it is 18 in this direction and then 15 down. Okay, scooting up. Okay, a third of A. So let's see, I've been doing A in purple. A again is 1, 2, 3, 1, 2, 3, 4, 5, 6. It's this far, right? That's the whole A, but I want a third of it. So if you think about this, if you just sort of divide this into 3 little pieces, can you see that we go over 1, down 2, over 1, down 2, over 1, down 2? Those are all equal, which means here in blue, that little piece is 1/3 of A. And again, algebraically, you can see it. Excuse me. All right, A is 3i minus 6j. And if you distribute, you get I minus 2j, which is exactly what that little blue vector is saying. Okay, scooting up. Here we go. We've got AB equaling 2i plus 3j and BC equaling this other thing. It says to find AC. Okay, so just a reminder. If I want to do vector addition to get AC, I need to have a head and a tail that are the same. So AB plus BC should equal AC. And I have AB and BC. So let's see if I can draw this. All right, so let me do AB first. So 2i and 3j. So here's AB. And then I need to add to that BC. So negative, I'm going to need to draw this higher. I can't get it to fit. Let's try here. Over 2, up 3, that's AB. And then BC is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So something like that. And then my answer is from the original tail to the new head. So something like this. Again, my picture's not very good because I can't use a straight edge, excuse me. I can't use the straight edge on the iPad. Or at least I only have a metal one, and it messes up the iPad. Anyway, let's just add these up, right? Let's do this algebraically. If AB is 2, that's a 2. 2i plus 3j. And B is negative 5i minus 7j. And we combine some like terms. This might even be easier than the graph. This is negative 3i minus 4j. Is that what this looks like? 1, 2, 3, 1, 2, 3, 4. It does. Okay, so for this next one, since I have actual locations based on a grid, let me draw in a grid real quick. All right, let's see if this works. Over 2 and up 1, 2, 3, 4. Let's put P right there. And then Q is at negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Ooh, man, that just fits. Okay, so there's where P and Q are. And it wants you to find vector QP. So starting from here and going to there. Now, again, you could just count it out on the graph paper. Right? You can count how far to the right and how far up you go, and that's totally fine. Okay, but keep in mind, sometimes these ordered pairs are going to be really, really far from each other, and you may not want to have to graph like hundreds and hundreds of dots and count them. All right, so just a reminder, QP, I can just do head minus tail, head minus tail, okay? So in this case, the head is P, the tail is Q, and if I do head minus tail, I believe I get a 7 up on top and an 11 on the bottom. All right, so this is the vector QP right here, 7, 11. All right, you could write it as 7i plus 11j. You could write it with the little other symbols that I still don't know what they're called. Anyway, or again, if the numbers are small enough, you could just graph it and count this out, and you'll see the exact same numbers. From here, that should be 7, and from here up, that should be 11. All right, this should be the last video. I should be back on Monday. Miss you guys.